Today, we will learn about a very interesting manufacturing process, and most of you are aware about this process. And this is basically our metal joining process, and its name is welding. Welding process is a metal joining process in which two or more parts are coalesced together at their contacting surface by suitable application of heat and or pressure. Okay, so as you can see from this diagram, that there is a plate, and it can be divided into two parts which are likely to join together. And then we have one heated source. That heated source that you have produced with the help of electric current or chemical combustion. So this heated source moves over the joint or the seam position, which is the joint made between these two plates to be joined, and then it causes the melting of material in a localized zone. This melted portion is known as the fusion zone. As you know, with the interaction of heat, your base metal also heats up. In the vicinity of this fusion zone, you have some part of the base material which is affected by the heat. This particular localized zone is known as the heat affected zone. So in a welding process, sometimes you need heat, sometimes you need pressure, or sometimes you need both. This heat can be produced with the help of electric current. Electric current is given to the workpieces. There is one electrode joined with your power supply. Whenever you bring this electrode and workpiece together, the gap between this electrode and the workpiece gets ionized, and then you have some heat generation due to the formation of arc. So this arc, what is this arc? This is a continuous spark. This spark has a very high amount of heat and very high temperature, which causes the melting and evaporation of the workpiece. In thin pieces, sometimes you don't require any extra filler material to fill the gap between the plates. Many times, if the plates are of very thick size, then you need certain filler material which helps or which facilitate the coalescence of the material. Such welding operations in which no filler metal is added are referred to as autogeneous welds. This happens in case of thin sheets which are less than 10 mm, and for the sheets which are greater than 10 mm, you certainly require some formation of groove and then some additional filler material to fill this groove or the gap between the plates. The whole joint part or the assembly of the part which you have obtained by the welding is known as the weldment. So in this diagram, you can easily observe that these are thick sheets which are to be joined together. Initially, there was some gap between them, and which is known as the groove. And then you have filled this groove with the help of your weld metal. So this weld metal came from the melting of the filler wire. Melting of the filler wire produced the weld metal, which filled the joint between these two plates. The weld metal is of very high temperature. Due to this high temperature and interaction of arc over this particular area causes some heating of the base metal, and this is known as the heat affected zone. So the weldment consists of your parts to be joined, the weld metal, and the heat affected zone. So this whole assembly is known as the weldment. After this, we will discuss about the classification of welding process. So the welding is mainly divided into two broad categories: fusion welding and pressure welding. First, we will discuss the fusion welding process. In fusion welding process, we require heating, and then heating causes the melting of the workpieces and fusion of the workpieces together. Fusion welding is further divided into three subcategories. One is the gas welding, other is the arc welding, and third one is the beam processes. So these three process categories are divided based upon the source of the heat generation in the welding. In gas welding, we use certain combustible gases. The heat of the combustion is utilized to melt the workpieces or to melt the filler wire and then to obtain the welded joint. In the arc welding, welding process, the source of the heat is the arc, which is produced by the application of low voltage current. The ionization of the gap between the electrode and the workpiece takes place, and which causes the formation of arc, and this arc causes the melting of the workpieces. And sometimes in some welding processes, the filler, you can say the filler wire or the electrode is of non-consumable type, such as in case of tungsten inert gas welding. So in that particular welding, the electrode is made up of tungsten and it has a high melting point. Therefore, this tungsten inert gas welding is used for the welding of thin workpieces, and it is primarily used for the autogeneous welding process. But sometimes if the workpieces to be joined are very thick, then additional filler wire is also required that you feed into the heated zone from the sideways. And in case of this power beam processes, you know that we have a beam of light or electrons. It is divided into two sub processes: laser welding and electron beam welding. In laser welding, you know the full form of laser. So laser is a light amplification by stimulated emission of radiation. So this is a monochromatic coherent beam of light made up of the beam of the photons, which impinges on the workpieces and causes the localized heating and vaporization of the material. Okay, in case of electron beam welding, we uses a beam of highly energetic fast moving electrons, which sometimes moves at very high velocity, and it can reach up to 33% of the speed of light. These fast moving electrons, when they strike the workpiece, they convert their kinetic energy into the heat energy, and it results in the localized melting and the heating of the workpiece. And then we have arc welding process. This is divided into two categories. One is the metal arc welding, and second one is the gas shielded arc welding process. In metal arc welding process, we have two welding processes. One is the manual metal arc welding process. The short form is MMA, or you can say other name is shielded metal arc welding process. So in this process, we uses a welding electrode, or this process is sometimes known as the stick welding process. So in this process, we use either bare electrodes, or sometimes we use coated electrodes, and then with the help of manual method, by using your hands, you move this welding electrode over the workpiece, and then you apply welding current, and the potential difference between the electrode and the workpiece, with the application of current and the potential difference, the gap between the electrode and workpiece gets ionized and heat is liberated. That ionization is cause the formation of the arc. This arc is full of energy or heat, and the temperature of this arc reaches from 3000 to 5000 degrees centigrade, and which causes the melting of the workpiece. And in this manual arc welding process, if you use bare electrode, then during the welding process you will certainly observe degradation of the material and very high heat transfer. Due to that condition, it may lead to the thermal stresses locking inside the material, which will eventually lead to the failure and the cracking of the material. So in order to overcome this problem, we use coated electrodes, which are covered with the help of a flux. The flux are the special materials which have the ingredients like silicates, it has some cellulose. So when the ingredients of the flux comes in contact with the arc, they burn and liberate a certain amount of gases, which causes a protective environment around the weld pool or the arcing zone. And the ingredients of the flux, they have also two components. One are the oxidizers and other is the cleansers. So oxidizer, what are oxidizers? Oxidizers are the ingredients which are used to prevent oxidation, and sometimes the base metal or your filler wire may contain some contaminants which may result in homogeneity in the weld metal. So cleansers ingredient, they perform the cleaning operation. They dig out the impurity from the weld metal, and then they forms some slag over the surface of the welded joint. Later you can break this slag, and then you can chip off this slag to get the cleaner weld material. So this is the manual metal arc welding process. And there are certain applications of your electrode. One application I have told you that it is used to fill the gap between the workpiece. The second you can say the use is to protect the weld pool from the atmospheric oxidation. The third use is to protect the workpiece from rapid cooling or quenching of the weld metal, because there will be high temperature gradient which causes the thermal stresses to locked inside the weld metal. During some actual application, your welded joint may get, sometimes if you want to modify the metal composition in order to get the higher strength and high corrosion resistance, you add certain elements or modifiers which are used to refine the microstructure of the metal. Sometimes it imparts good properties and corrosion resistance. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.